Okay, let's do this again. Oh, I did forget to update the stream title. Day 2 of daily live interview prep until I get a job. So I'll update that. And here we go. So we're back again. I'm starting later than expected, and I don't think it's going to be a particularly long stream, like maybe 2 hours, possibly 3, depending on what's going on. But I think like I'll shoot for 2 minimum. And we're going to start off straight away with some LeetCode. I chose a few reasonable looking problems to kind of warm up my brain, and then I'll probably move on to something slightly more complicated after that. So let's see, is everything working? So we got the music, we got my mic. We also have overlays now, so it was really easy to set up. Anyone who's thinking about trying to stream, I did it in like less than half an hour using stream elements. So follows will appear on the screen and play a sound, which I'm pretty hyped about because that will make sure that I don't miss them, because I've definitely been missing follows. So jumping right in, this is an easy problem just to kind of start off. So given a binary substring S, return the number of non-empty substrings that have the same number of zeros and ones, and all the zeros and all the ones in these substrings are grouped consecutively. Oh, okay. So we get 0, 0, 1, 1, 0, 0, 1, 1, and the output is 6 because there are 6 substrings that have an equal number of consecutive ones and zeros. Notice that some of these substrings repeat and are counted the number of times they occur, right? Right, so it's just, we're looking for substrings that, where the first, say, n characters are zeros and the second m characters are ones. And we just want to count those. So let's think about this for a second. So let's say that we have 0, 0, 0, 0, 0, 1, 1, 1, 1, 1. For that, we have, so we have the entire string. The entire string is one answer. Then we also have the first 4 zeros and the next 4 ones. And same thing for 3, same thing for 2. And then also we have the 0, 1 that's in the middle. So that's immediately 5. But then we also have a bunch of other ones, right? So we have, for example, 0, 1, 0, 1, 1, 1, 1, 1 would work. That's a valid answer. I'm pretty sure. Let me just check this. This seems like it's just a math problem. Like first you gotta find the segments of zeros and ones. So you take the original string and you split it so that you have like, you know that there's like 5 zeros, then there's 4 ones, then there's 3 zeros, then there's 4 ones. And the answers can also start with ones. It just has to be consecutive. Okay. So if we have, let's say that we have 2 parts. So for this example right here, 5 zeros and 5 ones, you could kind of represent this as 5, 5, as in, and well, so let's add a 0 on the end here. You could represent this as 5, 5, 1, because you have 5 zeros, then you have 5 ones, and then you have 1 0. And so assuming that we can fairly easily process the input string into something like this, then I think it's math at that point, because you could start the substring at any of these 5 zeros, and you could end the substring at any of these 5 ones. Am I thinking about this right? This is an easy problem, so I want to make sure I'm not overthinking it. Let me just read the description again. Given a binary string S, return the number of non-empty substrings that have the same number of zeros and one. Oh, it's got to be the same number. That does make it easier. Okay, I thought that so for example, I thought that like this would work. Just 0 followed by 5 ones, but that actually doesn't work. So that does make the problem a lot easier. So in that case, since the number of zeros and ones has to be the same, then the only other extra answer that we added by adding the 0 on the end is this. So that would mean that the answer for that test case is 1, 2, 3, 4, 5, 6. So we still want to break up the input so that we have it like this, where we just know what the number of zeros in the substring is. So we have 5 zeros, 5 ones, 1 0. And so once we have that, the question becomes, I think you basically take the min of, the number of zeros, whatever the character on the left is, you take the min of that and whatever the number of characters on the right is. So let's say that we have 1, 2, 3, 4, 1, 2, 3, 4, 5. So in this case, this would not be an answer because we don't have a 0 at the beginning, an extra 0, so that we can make this 5 0 solution. So for this one, we would have we would represent this as 4 4 4 5. But the answer would actually be 4. It would be the minimum of these two, right? Because the last one can't get used in one of the substrings that we're looking for. I'm pretty sure that's it. I'm pretty sure that's all we have to do. So we need to process the input so that we have it in this format. We could probably also just do it along the way, but I'll probably just pre-process it. And then we go through these like one pair at a time. So let's say that you had 1 1 0 0 0 1 0 0 1 1 1 1, something like that, which would be represented as 2 3 1 3 3 1, right? So 2 1s, 3 0s, 1 1, 3 0s, 3 1s, and 1 0. And so then you go through these one pair at a time, and you just add whatever the minimum of those two numbers is to the answer. So for this pair, 2 3, you'd be considering 1 1 0 0, and you take the minimum of those. The minimum of 2 and 3 is 2. And then you just add that to the answer, and then ultimately at the end you return the sum of all of what you found. And the reason, so just to review, so we got 2 3, which represents 1 1 0 0 0. We select 2, and that's because you have 1 0 and you have 1 1 0 0 as valid substrings that we're supposed to count. So let me switch over to a different language for the easy problem. I'll write this one. Oh, wait, I don't want to lose my test cases. Yeah, give me these, because I'm going to check these as well. So switching over to JavaScript, I'll just write this one in JavaScript. So the first thing we want to do is let's create this array. So we're going to iterate over the input string, and we're going to generate this. So let's just call it like lengths, and it starts off as an empty array. And then we're going to iterate through all the characters of the input string s, and we're going to try to create this. So for const c of s, and what we need is like a current length of the current segment that we're looking at. Current length starts off as 0, and then current or previous character, previous char. So the only chars that you can find in the input string are 0 and 1. So let's just set this to something completely different. indicating that essentially we have no previous char. So if the current character that we're looking at is the same as the previous char, then what we want to do is expand this current segment that we're looking at by 1. So we would have current length plus 1. And that's it. Else, if the current character is not the same as the previous char, then whatever the previous segment is now done. Like let's say we had 5 ones in a row and then we hit a 0. Now the previous char is different. So we want to terminate the previous segment and insert it into our lengths array. So previous char then becomes whatever C is. And okay, so let's do it this way. So if the previous char is not equal to -1, that means that we're not at the beginning of the array, we're somewhere in the middle. If the previous char is not equal to -1, then lengths dot push current length, right? And then we set the previous char equal to C. So let's just log that and see if it's right. So I'm gonna take this test case because I think it's more complicated than any of the ones in the sample. So let's run the code. All right, well, so something's already wrong. We're getting the wrong answer for 0011. So why are we getting 1 for the first one? So we start the previous char off at -1. We start the current length off at 0. If char is the previous char, then we increase the current length by 1. Otherwise, if it's not the previous char, if the previous char is not -1, we push the current length in. Otherwise, previous char. Oh, we also have to increase the length here, right? Plus equals 1. And we have to no, we need to reset the current length back to 0. No, it becomes 1, and it starts off as 0. Okay, so now we're getting closer. Now we have 222, but we're missing. Oh yeah. So this is a simple logic error. So once we get to the end, we just take whatever the current length of the previous segment is, and we also add that to lengths. So lengths dot push back. Not push back, just push current length. So if we run that, what's wrong now? That's not a very useful error message. Current length is not defined. But it's right here. Oh, okay. Yeah. So my brain is definitely still sort of in warm-up mode. Okay, so now that worked for this test case. Let's grab my my test case right here. And put that down there. Here, let me do it this way. So let me take both of the sample test cases and do those first, and then let me take all of my own test cases and do them next. Like, so then this would be 000011111. 1. Yeah. So that's the sample test cases at the top, and then my test cases. So then if I run this, we're gonna get a bunch of arrays. And so for the first one, we already know that's right. It's 2222. for the second test case, 1 0 1 0. That's right. We got 1 1 1 1. Then now moving on to my test cases. So 5 zeros followed by 5 ones followed by a 0. We do get the 5 5 1, which is what we want. And then the 4 5 works as well. And then 2 3 1 3 3 1. Okay, so this looks good so far. So we've taken the input string and we've converted it into this like array of lengths of the segments of zeros and ones. And now we just have to proceed from that array to the solution. So as I mentioned before, now that we have the pairs array, we're just going to go through them one pair at a time. We're going to look at each consecutive pair of lengths, and we're going to add whatever the minimum is to the solution, to the answer. So we have let answer equals 0, and then at the end we're going to return the answer. And then what we have is for let I is 0, I is less than lengths dot length minus 1. So we want to skip the last elements since we're going to be using I and I plus 1 in the loop. Plus plus I, and then answer gets increased by the minimum of lengths sub I and lengths sub I plus 1. Okay, run lengths sub I. So yeah, we got 6 4 6 4 6 4 8 6 4 6 4 8. According to LeetCode, we got the correct answer for the sample test cases and my test cases. So let's just submit that. Okay, there it is. So that's how to solve count binary substrings. A reasonably straightforward problem. Our memory usage isn't great, and that's probably because you probably don't need to do this step where you generate that array of lengths. You probably don't need to do it separately from this step. You could probably keep track, like as you're going through this loop, you could keep track of what the previous two lengths were, and then as soon as you start a new segment, you just take the minimum of the previous two lengths and you insert it into the you just add it to the answer. So essentially we can decrease our memory footprint by combining these two for loops into one. I think it would be pretty straightforward, but I'm not going to bother with that. Let's take a quick look at how they explain it on the solution page. So, okay, approach one, group by character. We can convert string S into an array of groups that represents the length of the same character contiguous blocks within the string, right? Okay, yeah. So that's exactly what we did. This is basically the lengths array that I created. They just call it groups. Then for every binary string of the form 0 times k plus 1 or 1 times k plus 0 times k, the string must occur between two groups. So let's try to count. Yeah. So they just explain it and they end up with the same observation that I made earlier, which is that we just take the minimum of the two groups and that's the answer. It would be interesting if they had level 2 of this problem where you also need to count, for example, like if you also need to count entries like this, right? So 0 0 1 1 1 is a substring of the input, but according to this problem description, it's not one that you need to count because the number of zeros and ones are not the same. But it'd be cool if there was a version of maybe there is, maybe it's just called something different. Let's think about this for a sec. So what if you did need to do that? What if they wanted you to count like these as well? So So let's take this test case and let's move it down here. Let's rewrite it to be this, which in array form, after we process it, we would get 5, 5. And so I think the idea here would be that you can start the substring at any of these zeros and you can end it at any of these ones. So the number of possibilities would be this times this. Is it that easy? Would it just be 5 times 5? So if it's 5 times 5, that would be saying that there's 25 different ways that you could create a substring out of this. So you'd have 0, 1. Let's just think about this for a second. You'd have 0, 1, 1, 1. You'd have 0, 0, 1, 1, 1, 1. You'd have 0, 0, 0, 1, 1, 1, 1, 1. You'd have 0, 0, 0, 1, 2, 3, 4, 5. And then you'd have the full string as well. So that would be 5 of the solutions that you would need to count. So, okay, yeah. So this would be 5 of the things you need to count. But then think about it this way. Then you need to take these exact same 5 that you already found and also count the ones where there's one less 1 on the end, right? And so that's another 5 that you need to count. Then you need to count the exact same ones, but with 1 fewer ones on the end. So that'd be another 5. And so you could do that 5 times, and I think you would end up with 25 unique, what do they call them? Binary substrings that you would need to count. So yeah, that's not significantly more difficult, but it is an interesting twist on the problem. So let's leave that. Let's get rid of this. Let's submit this just a few more times to get kind of a range of what the runtimes are that we're getting. Yeah, so the runtime is good. Like, this is pretty optimal runtime wise, like big O wise. But as I mentioned before, we can improve the space that we're using just by not using this array of lengths and combining these two for loops together. Okay, so that's that one. Let's move on to encode and decode strings. I just want to, so that's like the next problem that they recommend. I have other problems here that I have to look at, but let's go ahead and take a look at encode and decode strings, and let's just see what it is. Design an algorithm to encode a list of strings to a string. The encoded string is then sent over the network and is decoded back to the original list of strings. Oh, interesting. This is like a kind of an open-ended one. I like it. I like these. They kind of just say like, this is what it. I don't know how to explain it. Like they're basically like saying, implement a system, but how you do it is up to you. So like, there's a lot of different ways you could do something. You could like encode them as base 64. I don't know how to do that off the top of my head, but here, I don't know yet if I'm doing this in JavaScript, but actually let's leave those comments. Because yeah, so encode takes the strings list and returns the encoded string. Decode takes the string and returns the string list. So machine 1 has the, so we got that. Machine 1 gets the encoded string from the list. Machine 2 gets the list from the encoded string. And then obviously the strings that machine 2 decodes should match the original strings that were encoded from machine 1. Implement encode and decode. You are not allowed to solve the problem using any serialization methods such as eval. Yeah, that makes sense. That makes sense. Because in JavaScript, for example, I could do this. Return JSON.stringify strs. Return JSON.parse s. And I'm just going to run this for fun, but this would work, but this is not what they want you to do, right? So JavaScript's built-in JSON functions run really fast, so that's a good sign, right? Just by using JavaScript's built-in JSON stringify and parse functions, we're getting a runtime of better than 95% of JavaScript, and with significantly less memory than all the other submissions on average. But alas, that's not what they want us to do. They want us to actually write it ourselves. So let's just take a look at this. So strings sub I contains any possible characters out of 256 valid ASCII characters. So here's what I'm thinking. A simple way to encode this, I think, would be to just concatenate all the strings together and include a delimiter character in between them. But then the problem with that is whatever delimiter character you choose, you then have to encode that in the strings so that when it gets decoded, those don't get treated as delimiters. So for example, if you had the list A and B, you could produce the string A pipe B, right? And that would work as long as neither of these strings contains a pipe symbol in it. If you had A pipe B C, like that, and you do it naively, the encoded string is going to look like this. And then when we decode it, we would get this. We would get that, which is not the original list of strings. So alternatively, what you could do is, this is very common in software development. What you want to do is you want to escape. I think you want to escape the delimiter. So, for example, this delimiter becomes like a slash delimiter. And then that would make sure that when you parse this, you get the original thing back. But I think there's also edge cases now, because now the slash character also needs to be escaped, I think. So let's say that we had B slash right here. The way we would encode that is as slash slash. And would that just work? So what I'm thinking is, in the original set of strings, pipe would get escaped to slash pipe, and slash would get escaped as well to slash slash. Then the question is, what if we had a slash slash here? If we had a slash slash there, it would get escaped to 4 slashes. I think this will work. I don't know. I've never implemented like an escaping mechanism like this before, but this seems reasonable. I'm just trying to think if there's any other edge cases that this won't work for. So the delimiter is going to be a pipe symbol. So we go through the input strings and we replace any pipe symbol with a slash pipe symbol. And we replace any slashes with a slash slash. So we're escaping the pipe symbol and we're escaping the slash symbol. And so a pipe b slash slash becomes a slash pipe b slash slash slash. Then when we come to the decode step, before we split on pipes, we first unescape. So we would unescape the slash pipe, and we would unescape the slash slash, and we would unescape the slash slash. Yeah. So in the encoded string, anything that starts with a slash is escaped. And yeah, okay. I think this would work. I think this will work. Because of the way. So the rule for the encoding is that in the encoded string, anything that starts with a slash is escaped. So when we come to decoding it, the first thing we would do is we would unescape these, this, and then this one. After we unescape this and this, then this pipe is not escaped because it doesn't start with a slash, which indicates that that's a delimiter that we then need to split on to get the answer. I think that's going to work. We just have to be smart about it, right? So the encoding step is easy. Any instances of pipe and slash just become instances of slash pipe and slash slash. But then the decoding step, we have to be careful because these two become a pipe, these two become a slash, these two become a slash. And then I think maybe we keep an array of like the indices of unescaped delimiters, like actual delimiters. And then we can split based on those. So we could iterate, I'm trying to think about how I would iterate through the encoded string to produce this. That's what I'm thinking about right now. So I could iterate through one character at a time, just, I equals 0. I goes through the length. We encounter an A, ignore it. We encounter a slash. Because we encounter a slash, we know that we're dealing with an escaped character. So whatever the next character is what it's supposed to be. So this just becomes a pipe. Then we go on to B, ignore it. Then we have a slash, so we know that whatever is next is escaped, so it's slash, and then it's slash. And then we come to a pipe symbol, and because we already processed these, right, we know that it's not an escaped slash. It looks like it could be an escaped slash, but the way to think about it is that we're processing this from left to right, and if we've already determined that these two pairs form an escaped slash, and we've determined that these two pairs form an escaped slash. So this pipe is not escaped because it's by itself. Yeah. Okay, let's start trying to code this up. The encode step I think is easy. It's decoding it might be a little bit more tricky. I'll just keep using JavaScript because why not? So let's do let encoded is an empty string, and then that's what we're going to return. And then for C of for stir of stirs let's see. So in JavaScript, there's like a regex replace, right? I think we probably could use something like that, or a string replace, JavaScript string replace. Is that going to be the most efficient, or is it more efficient to do it one character at a time? It's probably more efficient to do it one character at a time. For const C of stir, so for C being the current character, encoded if C, so here we use a switch here. If C is a slash, then encoded plus equals slash slash. Otherwise, if it's a pipe, encoded plus equals slash pipe. So we're escaping the slashes and the pipes, and then break. Then the default case would be encoded plus equals C. And then after that for loop terminates, encoded plus equals a pipe, like this. And then that's going to give us one extra pipe at the end. So we could probably, there would be a fairly straightforward way to avoid that, and that's by doing like an actual iterator, like integer. I is less than stirs dot length So we'll do that instead of the for of loop. And then what we can do is up here, if I is greater than 0, so if we're not at the first index, we can just we can add the pipe onto the encoded string right here. You could also do it at the bottom. So if I is not the last index, put the pipe on in it, but this works too. Okay, so return encoded. So let's test that. Let's test that. So console.log, we'll just run it down here. Encode, and then we'll just use my sample case that I came up with down here. So if we try to encode that, let's see what we get. Okay, and I don't think I need these descriptor comments now. I have a pretty good idea of what these functions are supposed to do. Wait a minute. These are supposed to be backslashes. Should I use forward slashes? Backslash is like built-in, built-in escaping. Let's try to use a different character instead. Let's try to use forward slash. I don't wanna try to I don't wanna accidentally collide with like built-in JavaScript escaping mechanisms. Okay. AB //. So A slash pipe B / pipe C. That's not right. Oh, okay. Here we go. That'll do it. Yeah, okay. So I had a bug here where I was basically testing an impossible case where a single character is equal to the strings //, but okay, cool. So that looks right. So that's the same thing that we came up with down here. So that's the decode step done. That's the encode step done. Now we need to decode it, which is going to be trickier, I think. So we are going to have const stirs is an empty array, and we're going to return stirs. So let's just start off by iterating through the encoded string. I is less than encoded.length. Okay. And so now we're iterating through the encoded string. Anytime we encounter a slash, a forward slash, we know that it's an encoded character. There's no other possibility. So anytime we encounter a slash, that character and the next one form like an escaped pair. Okay. So maybe we can do this. This might actually be a pretty efficient solution. Let stir equal empty string. So basically, this stir right here is the current string that we're building, and then as soon as we encounter the delimiter, which is a unescaped pipe symbol, then we'll take the current stir, throw it in our stirs array, which is the answer. We'll reset stir to empty string and proceed. So, but I do need to do this iteratively, because what I'm going to do is we're going one character at a time, but every time I encounter an escaped character, which is 2 characters long, right? You've got the slash and then either a slash or a pipe. I'll actually increment I again within this loop to move past it. So that's what I'm going to do. So we'll get the character out though, just so that we have that. The character is encoded sub I. And then let's switch. No, we don't need to switch. We can just do if. So if the character is a forward slash, then we know that this character and the next character, which is at I+1, we know that they form an escaped pair. If C is not slash, then all we do is stir plus equals C. And we keep going. Oh no, there is another possibility. there is a very important possibility, which is if C is pipe, then we're at a delimiter. So we need to handle that case too. So, and it's not possible, very, very important to note is that it's not going to be possible for us to hit this case if we're talking about an escaped slash, because this case right here will handle it. And let's just do that right now. So, this is going to be stir plus equals encoded of I plus 1. That's going to be, and then we increase I. So that we skip the next one.
Don't be afraid to borrow.
Now, if C is a pipe, that means that we're done with the previous string. So we take our stirs array and we push the new string onto it. And then we reset stir to empty string. Okay, and then if it's just a normal character,
that's one of the reasons why I can churn stuff out.
Then
I don't have
we just add C to the string.
Or borrowing something that I heard.
Okay, I think we're good. So then the next thing is, this is very similar to the last problem actually, is when we get to the bottom of this for loop, whatever the current string is, we just add that to the solution. So strings dot push string. So console.log decode of encode that.
So once you get over that, sounding good is easy.
Okay, so that's right for that case. Let's comment this out and let's run some other test cases.
And pretend, like it's yours. No one will know.
Okay, so they do have an empty string test case, which is useful to have. I'll just throw my test cases in as well.
No one knows.
So
New generation.
we'll use this test case. Replace the single quotes with double quotes, and we'll also use this test case too.
Obviously, chords and melodies, there's only so many.
Let's skip this song. Let me just switch this to instrumental only.
Don't be blatant about it.
Okay. Oops. Okay. All right. So we got the 4 test cases. The two sample test cases for hello world and empty string, and then my 2 test cases. So let's run it. Okay, so we get accepted for the 2 sample test cases and my 2 test cases. Let's just, before I submit, let's just think for a second about whether or not it's possible for whether or not there's any other edge cases that we might be missing. So we're already checking the empty string test case. We should check a test case where it's just like one word by itself. Let's check it with like one word by itself that's got like pipes and slashes in it. Let's just put a bunch of pipes and slashes in here, like this. That's probably a pretty good test case, right? Add some more characters onto the end. And let's run that. Okay, so all of that passed, even this ridiculous case right here. So hopefully this is going to be accepted on the first try, but let's see. Let's go. We got it. It does run slower though than JSON.stringify. So I don't actually know quite. Well, I think I know why that is. Like JSON.stringify is going to be implemented in like a more efficient language. Like JSON.stringify probably runs, like it's probably implemented in C++ and it probably runs directly on the CPU. Whereas my code is running on the the JavaScript runtime. So if I rewrote this solution in C++, I think that I would probably be able to get it to be a lot faster. I am kind of surprised by this though. My solution is only faster than 36% of JavaScript submissions. And that actually, this kind of makes me wonder if a lot of the JavaScript submissions are just using something similar to JSON.stringify. But in any case, that's accepted. Let's submit it again, get a couple more measurements. Okay. That was a fun problem. So reviewing that problem, basically the task is actually really simple. And I like how they leave the solution open-ended. You can kind of implement it however you want. You get an array of strings, and your job is to encode it into a single string. Then you also have the decode function, which takes a string that was produced by your encode function and parses it back into the original list of strings. And so our first submission, we just kind of demonstrated that you can do this in one line of code using JavaScript's built-in JSON.parse and JSON.stringify functions. And in other languages, there's almost certainly something very similar that you could do. Just in JavaScript, JSON.stringify and parse is probably the easiest. Then after that, we actually implemented it. And so the way that we implement it is using character escaping. And so by character escaping, basically what I mean is you define a special character as being like your escape character. In our case, we chose the / as our escape character. And then you have to define another character as your delimiter. And so the delimiter character is going to get, essentially in your encoded string, the delimiter character is just going to be sitting in between the original strings that you'll eventually have to decode. So in our case, we use pipe symbol. So in the encode function, we just go through all of the strings, and we go through all of the characters. Anytime we encounter a slash in one of the original strings, we have to escape that into a //. Similarly, anytime we encounter a pipe, we have to escape that into a /pipe. Otherwise, if it's neither of those two possibilities, we just encode the C. Slightly more streamlined way to write this logic is if C is slash or C is pipe. This is actually a better way to do it because it kind of lets you see in one line of code all the characters that you're escaping. Encoded plus equals slash plus C, else. Oh, okay. So you can actually do it this way. Because we always end up having the original character in the encoded string. It's just the case that if we ever encounter a character that we want to escape, we need to precede it with the escape character, which is the /. So this should still work. And then the decode function is basically just the inverse of that. The important observation here is that when you're iterating through the characters, one character at a time, anytime you encounter the escape character /, you're guaranteed to be at something that you originally escaped in the encode function. So essentially all you do is if you encounter the / character in the encoded string, which is the escape character, we could probably have like a const escape up here, you know, escape char equals /, and then you could reference this throughout the code, and that would be more readable. And then this is the list of the characters you want to escape, and that includes the escape char. So const characters, we'll just do it like this, chars to escape. So you just have a list of the characters that you care about escaping. The only time you need to escape a character is if it has special meaning, right? So the escape character itself has special meaning. So that obviously needs to go in there. But in our case, the other character that has special meaning is the delimiter. So this would be a better way to write this. In an interview, you would definitely want to write it something like this. In a coding contest, just code it up literally as fast as you possibly can. And doing this might actually take you longer, depending on how you approach the problem. But yeah, so we have our escape character and we have our delimiter. These are the only two characters in the encoding that have special meaning. And so those are the two characters that we want to escape. So we can create a new set that contains the escape character and the delimiter. And then what we can do here is if chars to escape dot has, right now what we're doing is we're just revising the code slightly to be a little bit more readable, and this is definitely one thing that you would want to do in an interview. So if the chars to escape includes the current character of the string, then the first thing we do is we add the escape character to the encoded string, and then we add the character. Otherwise, this if statement doesn't run, and we just add the character by itself. And then right here, this would be the delimiter. And so this is basically saying that as we're encoding the string, we insert the delimiter in between each string that we're encoding, right? So that seems pretty logical. And then down here, you would have something very similar. It doesn't actually change that much. You change this to delimiter. So if you encounter the escape char, you just take whatever is next. You take the next char after it, and you be sure to increase I. Otherwise, if it's the delimiter, you terminate the current string, you add it onto your list, and then you reset the string to be empty. Otherwise, if the current character is neither the escape character or the delimiter, you just take the character. It's just a normal character that represents itself. It just goes into the answer. So that doesn't change the code that much. That's not going to change my runtime at all. In fact, for some reason that my runtime is going up because of that. I think it's just because LeetCode's like runtime calculator is pretty inconsistent. Yeah. So we had like a bunch in the 200, and then it just randomly jumps back down to 147 for whatever reason. I would probably rename this to delimiter char, just for consistency. Yeah, right now this is not a particularly complicated problem, but I'm just going through the code and showing ways that you could make it slightly more readable and impress your interviewer, but don't bother doing this in a contest for obvious reasons. Then the only other thing, It's honestly kind of probably a bad thing to do because it decreases the readability of the code. But if you wanted to, you could do ++I right here. So because the plus plus... Oh, shut up. Google Assistant just coming out of nowhere, chatting with me. Because you're using the plus plus in front of the I, that means it's a pre-increment. So essentially I will get incremented, but it gets incremented before it gets used in the rest of the expression. So if I is 0, the first thing that happens is it becomes 1, and then we grab the 1th index out of encoded. So you could do it that way. It's not going to change the runtime at all, but it will still work. Okay, so with all of that out of the way, let's just take a peek at the solution. Let's see if they suggest... I have a feeling that there will be a solution in here that's just escaping, which is what I'm doing. Let's see if they suggest anything else that I didn't think of. Okay, approach 1, non-ASCII delimiter. Interesting. Yeah, so that makes sense, right? So they basically guarantee in the constraints of the problem that you're only going to be dealing with 256 valid ASCII characters. So instead of doing what I'm doing with the escaping, you can just choose another character that's not one of the 256 valid ASCII characters, and you can just insert that as a delimiter. And maybe that's why my code is slow, because that would be faster. So what's the delimiter that they're using here in the Java solution? It's this. Okay, yeah, I see. So they're using the string builder, but for the delimiter, they're taking the 257th character, and they're just using that. They're appending it after every string, and then they just remove the last one, which is a problem that I solved just by not adding it at all. Time complexity, O of n, space complexity, O of 1. I mean, I didn't talk about that for my solution, but I'm pretty sure that that's the case. Yeah. So time complexity is just O of n for both. And then they distinguish between the time complexity, the space complexity of encode versus decode. And that makes sense. So encode is O of 1, decode is O of n, because you're creating the array of strings. Okay, approach 2. This looks interesting. Chunked transfer encoding. Pay attention to this approach because last year Google likes to ask that sort of low-level optimization. Serialize and deserialize BST problem is a similar example. Let's just open that and maybe take a look at that later. This approach is based on the encoding used in HTTP version 1.1. It doesn't depend on the set of input characters and hence is more versatile and effective than approach 1. Yeah, but mine also doesn't depend on that though. Like my approach doesn't depend on the 256 valid ASCII characters. You could use any character and any set of characters and this would still work because of how I'm using escaping. So data stream is divided into chunks. Each chunk is preceded by its size in bytes. Interesting. So the input is ABC, then DE, then CCC, whatever character that is. And so then you basically just have pairs you have pairs of data in your encoded string, where it looks like here the first 4 bytes, every single string is preceded by 4 bytes. So every single string is preceded by a 32-bit integer, which just represents the number of bytes that are about to come up after it for that string. So you got 3 ABC, 2 DE, 3 CCC. So the encoding algorithm, you iterate over the array of chunks or strings. For each chunk, compute its length and convert that into a 4-byte string. Append to encoded string. Oh, that's smart. I like it. And apparently this is something that Google was asking recently. Oh wait, when was this problem written? I don't even know where to see that. So I don't know how recent this note is in the solution, but so for decoding, it's pretty straightforward. You read 4 bytes, and then you turn that into a length, and then you move the pointer forward by 4 bytes, and then you append. Yeah. Okay. All right. I might actually want to come back and write it that way, because that does seem like a fun thing to do. Yeah. Okay. So here's the code for that. I'm not gonna read it because I kind of want to do it myself later. Okay, so interestingly, the solution that I wrote is not one of the approaches that they cover in the solution page. They cover using a non-ASCII delimiter, and they cover using the chunked transfer encoding. They don't cover it using an escape character. Let's see, the people mentioned that in the comments. What if the length of string exceeds integer max value? Well, then you just need to use a longer number of, you need to use more bytes for your data. Okay. Here we go. Here we go. I saw a very clever solution which uses some special character, for example, / to denote the end of the length of the string. For example, 443 would mean the string is 43 characters long. Here we go. I just wanted to see someone doing it the same way I'm doing it. Okay, so prefix length is very similar to the chunk transfer encoding that we just talked about. The codec, man, they really implemented it in like 3 lines of Python code. Return /t.join and then /t.split. Oh, there. No. This technically isn't using an escape character. Well, it is, but I'm like actually doing the escaping and unescaping in my solution. This is just using a tab character. Like, as far as Python's concerned, this is one character, right? It like internally in memory, it stores /t as a special character, which means tab. Whereas in my solution, like // is 2 characters. So this solution right here is exactly the same as the non-ASCII delimiter, because the tab character is not one of the 256 ASCII characters. All right, that's enough of looking at that. Let's look at the discussion. Java with escaping, that's kind of what I wanted to see. Yeah. This is what I did right here. This is what I did. They use # instead of /. Yeah, okay. All right. So let's consider that problem done for now. I could potentially come back and implement it with the chunk transfer encoding. Well, I want to move on. Let's move on from that problem. So I found this one earlier and I thought it was interesting. This one is, the task is to design a file system. You are asked to design a file system that allows you to create new paths and associate them with different values. The format of a path is one or more concatenated strings in the form of slash followed by one or more lower English case letters. For example, /LeetCode and /LeetCode/problems are valid paths, while an empty string and slash are not. Implement a file system class. Bool create path, string path, int value, creates a new path and associates a value to it. If possible, returns true, returns false if the path already exists or its parent path doesn't exist. Okay. Return the value associated with path or -1 if the path doesn't exist. Okay. Don't mind if I do. So the parent path has to exist. The number of calls to the to function is less than or equal to 10 to the 4 in total. Python 3, JavaScript. I'm just trying to decide what I want to use for this problem. But I probably shouldn't think too hard about this specific detail. I haven't implemented a solution in Python today. I'm a Python noob, so the first thing I do is I remove the type definitions, because whenever I write Python, I don't use those. Okay. So here's what I'm thinking. You can represent the file system as a tree, obviously. You have a root, and then all the directories under the root are its children, and then those directories can have children that are directories. And I think that you could definitely implement a solution to this problem that is space efficient. Because like every directory is only represented once in the tree. But as far as like just solving this, like I'm trying to figure out why we can't use a set or a map. That's what I'm trying to figure out. Python create empty map. Dictionary, okay. In Python, they're called dictionaries. Okay, and it's just curly braces, or you can use the dict function. So here's what I'm thinking, right? Okay, so when you create a path, the parent path has to exist first. So we are going to have to handle that. Let's just call this FS for file system. Oh, does this need to be... Man, I haven't written Python in a while. This needs to be self dot. Hold on, I apologize for being a Python noob right now. Python class instance variable. Like, do you have to put self dot in front of everything? Show me an example of a class that has functions in it. Why was that completely useless? Self.name equals name. Yeah. And but then if I wanted to reference the instance variable, huh? This is wrong, right? This is supposed to be self.name and self.age. Yeah, it is. That was wrong. Should I leave a comment on this file saying that that's wrong? I don't think I'm gonna bother. It's pretty easy for people to see. I think that that's wrong, but so in the constructor, you can do self dot to assign instance variables, and then in the instance functions or instance methods, you reference them with self dot. So this is right. Self dot fs equals empty dictionary, and then self dot fs path equals value. So are the paths guaranteed to be valid? That's annoying. It doesn't actually specify that. The format of a path is one or more concatenated strings of the form slash followed by one or more lowercase English letters. For example, slash LeetCode and slash LeetCode slash problems are valid paths, while an empty string and just slash by itself are not. The only clue that they give as to whether or not they're going to supply you invalid paths, like in the input, are that it says that these two paths, empty string and slash, are not valid paths. And then in the create path function, it says create a new path and associate a value. Return false if the path already exists or its parent doesn't exist. And then get path. So, and the number of calls to the two functions is less than or equal to 10 to the 4 in total. So that kind of indicates to me that I can use a dictionary for this rather than a tree. I have a feeling that tree is what they want you to do. Tree's definitely the more space efficient solution, and creating a tree data structure like better represents the actual structure of the file system. But I'm curious to see if I can implement this as a dictionary and still get it right. So that's the path I'm going to go down. However, I'm just going to take a quick break here. I'll use the restroom, refill my water, and then I'll be right back, and I'm going to try to implement this problem using a dictionary. So let me hop over to the be right back screen, and I'll be right back. Okay, let's go back to it. So let me look at the constraints again. The maximum path length is 100, and they're going to give you a maximum of 10,000 paths. Okay, so let's try implementing this as a dictionary. The first thing I'm going to do is validate that the path is legit. It's a good path. Do they say anything about what? Okay, so it can only be slashes and lower English case letters. It doesn't end with a slash, and it can't be just a slash by itself, and you probably can't have like two slashes together. So let's create a regular expression to just check that it's good. And because I'm doing that, I'm going to switch over to JavaScript, just because I'm more familiar with writing regular expressions in JavaScript. So this must be an old problem, because they're using like the old way of doing JavaScript classes, where you have you put your instance methods on the prototype. This.fs equals new map, and then when you create a path, let's do if not is valid path return false, because we're supposed to return false. It says we're supposed to return false if the path exists or its parent path doesn't exist, but I just assume that we're also supposed to return false if the path's not valid. It doesn't say that, but that just seems to be a reasonable assumption to me, so let's go with it. Prototype.isValid path. I don't actually need to do it this way. Here, I'm not going to do it that way. I'm just going to create a function up here. This is how I would usually do it. A little bit more modern syntax. It would be isValid path. So it would be like that. And then, yeah, this will just be able to reference that. So we need a regex. So first of all, let's just check that we only have lowercase English letters and forward slashes. So if not A to Z plus. Is that right? Let's see, JavaScript regex. I'm trying to write a regex right now that just confirms that the path is valid. So it is forward slashes. And then regex match. Yeah, and it returns null if no matches are found. So if not path dot match. Oh, sorry, it's forward slashes. Yeah, there we go. I was hoping that I would get syntax highlighting for that, and I just had to do that. I have to change the backslashes to forward slashes. Okay, so let's just test our isValid function a little bit. Console log isValid. so here's what we're expecting. Let's have these out a little more. Get a nice little table-esque format. I don't really care about LeetCode. We'll just do like /a. /a/b should be valid. /a//b that should be not valid, and /a//b/ should not be valid. Okay, so let's just run this. I want to make sure that I get my validation function working first. And this needs to be like that. Okay. So we get false for empty string, which is good. And we get false for 1, 2, 3, which is good. We get true for everything else, even though there should be some falses in there. So we got to make sure that the length can't be 1. Actually, we can just do if path.length is less than 2. That's not valid. So that takes care of that. So now we just need to deal with these situations. If there's any double slashes, then it's bad. If path.match, or I could just do if path.includes double slash, return false. That will also work for triple slash, any number of consecutive slashes. Okay, so now we're getting closer to what we want. We've got 5 false, and so we just want to make sure that the last character is not a slash. So if I change this to star and then I put a not group here, this will work, right? Not that. Will that work? Yeah, that works. So basically what I did was I said we want any number of oh wait, it's not supposed to start with a slash either. Where am I checking for that? Oh wait, sorry, it is supposed to start with a slash. It's not allowed to start with not a slash. So for example, I shouldn't be able to do A, and I shouldn't be able to do A/B either. Like neither of those is good. So but right now my code doesn't handle that, but I'll implement it in a second. So yeah, so it shouldn't be able to start just with a letter. It has to start with a slash. So basically, I need another one of these. Oh no! I just need I can just do this. So this is basically saying has to start with a slash, then it has to have any number of lowercase English letters or slashes, and then this is saying it cannot end with a slash. Also, if it has a double slash in it, let's check that first. Then that's also wrong. And that might be everything we need to check for this problem. Okay, so we can do something like this. I know that I could just like return not this whole expression, but this reads a little bit better for me. I can see like these are the things that are for the false case really easily this way. Hey, what's up? Not enough study streams. Sorry I missed your message. I'm not sure how long ago you hopped in and sent it. So yeah, I'm working through this one right now. I have thought of two approaches. I think one of those two approaches is what they want you to do. And I think the other of the two approaches, I think it's going to work, but I don't think it's what they want you to do. So I think what they want you to do is build a tree. So every time that they create a path, they always create paths as child paths of paths that already exist. Otherwise, it's not valid. So like if they give you /a, then you start off with like an a. Then if they give you /a/b and /a/c, basically what you're doing is you're building a tree out of this. So you would take the B and the C, and those would become children of the A. I think that that's what they want you to do for this problem, but I'm trying to implement it in a different way that doesn't require me to build a tree data structure. But it is going to end up using more space though. So if I end up getting this accepted, I expect my space to be pretty bad. What I'm going to do instead is I'm going to use a map or a dictionary, whatever you want to call it, that just keeps track of all the paths that have been provided so far. So like they give me /a, I'm just going to throw it in the map. They give me /ab. It's also worth noting that every time they give you a path, they also give you a value associated with it. So they give you like a path and then an integer, and you have to associate the integer that they give you with that path. So it would be like something like, I don't know, a goes to 4, this could be like 17, like it could just be anything. And so that's why I'm using a map, because I'm just going to have a map that goes from strings to integers. But in JavaScript, you know, it's fairly loosely typed, so I just define it as a normal map. And I'm going to, every time they give me a path and an integer, I'm just going to throw it in the map if it doesn't already exist. If it already exists, we're supposed to return false. And then there's this other requirement here, is that the parent has to exist. So if you were building a tree out of this, let's say that they give us /a, then they give us /ab, and so we have this left side of the tree, and then they give us /a/c. What I would actually do is, before I create C, I would be able to first ensure that A already exists. So you'd kind of like traverse down the tree throughout like the segments of the path that they give you until you reach the bottom, and then you would add a new node. But I think that this is really easy to do with a map though, because I think all I need to do is every time they give me a new path, I just chop off the last segment. So I chop off the /c, and then I can check to see if /a is in the map. So that's what I'm trying to do right now. And like I said, I don't think that's what they want you to do. I think they want you to make a tree. But I just want to see if this works. But the first thing I'm doing right now is I'm just trying to make sure that I can validate whether or not the paths they provide are valid. And I think I'm good on that now. Let me run the code. Okay, they're not letting me comment that out. Probably because it had slashes in it already. I'll just copy that somewhere else for now. Okay, yeah, so for these paths, we're getting the expected answer. False, 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 true, true, false, 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 false. Like, I think that I could probably include both of these checks here for the length and the double slash. Like, I can probably include that in the regex, but I'm not quite good enough at regex to know how to do that off the top of my head. Actually, I think I do know how to do the tooth part, but I don't know how to do the double slash part. So I'm just doing it this way. So now that we have all of that, I'll comment that out, and now we know that the path is valid. So what we want to do is we want to do this.fs path equals value. But first we have to make sure that it doesn't exist. So if this.fs path, if this.fs path is not equal to null, hold on a sec, what does map return if it's not in there? JavaScript map, because the thing is, there could be zeros in there. Map.get, and it returns undefined, so I can just use that. So basically, if this.fs okay, yeah, I can just do has, actually. I forgot about that. So if the file system has the path already, we can just return false. And then this is actually not right. This needs to be fs dot insert question mark. Oh, set path value. So we still need a little bit of logic right here, and then in get returns the value associated with the path or -1. So it would be return this.fs .get path, and then what I can actually do here is I can use question mark -1. And so question mark is kind of like an or, but it's only if this value is null or undefined. It's kind of a cool feature that they added to JavaScript somewhat recently, actually. I could do or here, but the problem with that is 0, I think, is a valid number that could be in here. And so if there's a 0 in fs.getPath, okay, according to the problem, it can't be 0, but let's just say hypothetically that it could have been 0, then question mark is what you would have wanted to do there. And this is going to work anyway. This will work either way. So if fs.getPath returns undefined, then this whole thing will return -1. Okay, so this is almost done. If I run this, null undefined 1 should be null true 1. Oh, okay. So this needs to return true at the bottom. Okay, so I pass the example 1. I don't think I'll pass example 2, right? There's going to be something wrong with it. Right, and that's because I assume that what they do in example 2 is they try to create a path that doesn't have a parent. Yeah, it's right here. So they tried to create path CD, and you cannot create path CD unless you already have path C. So this is where this comes in right here. So if this.fs.has, and we want to get a substring of the path, path.substring, and we want to do the substring that cuts off the last segment. Assuming that, that it has one. If it only has one slash, then we're good. Let's see here. But let's just get the substring part first. So the substring is going to be starting at one index. Well, no, it's going to start at 0, and it's going to proceed until the last slash character, which is going to be path dot last index of slash. So if that's not in there, then I think we return false. Also, let's just make sure this is right. Const parents path equals all of that, and let's just log that to see if we're actually doing that right. Okay. So we're getting a lot of empty lines here in the standard out, and that's because I only need to check this if the path is like got more than one segment in it, because like a top level path is always valid. /A is fine. /A/B we need to check to make sure that /A is there. So that's just going to depend on how many slashes are in the path, so I could just count those. Oh, you know what? No. This will actually work fine, because if the path is just /A, then this is guaranteed to be an empty string, because the slash is the last index of slash is the only slash which is at 0. And substring 00 returns empty string. So basically, if parent path and it's not in there. And this works because empty string in JavaScript is just false. It evaluates to false in Boolean situations. And then anything else, like a string with anything in it, will be true. So we're getting accepted now for the examples, and now's kind of the moment of truth where I submit it and see if it's good. Accepted. Cool, we got that one. I'm actually surprised that it did that well, because I thought this was not how they would want you to implement it. I'm gonna go take a look at the solution page in a second just to see what they recommend. Let's get a couple more measurements for the time and all that stuff. Okay. Well, it's also possible that not many people have submitted JavaScript solutions to this, which is why I'm getting such a, like, that's a really high reading. Like, that's basically saying this is the fastest JavaScript solution that exists. and the most memory efficient one. So that's interesting, but okay, so that did work. I'm gonna remove all these comments. Yeah, let me know if you want me to explain anything about this. Okay, let's look at the solution. Okay, approach 1 is dictionary for storing paths, and that sounds like exactly what I've done here. So simulation-based approach because it doesn't use any fancy data structure for storing the paths, and we do what the problem asks us to do. We simply need a key value data structure with some additional processing to verify the validity of a path. Hash map or dictionary is a good data structure to go with. Let's look at a visual representation of how a hash map would look as we keep adding more paths to it. Right. Retrieving the value. Okay, yeah. Blah, blah, blah. So I'm expecting this to be pretty much the same thing that I did. Yeah, it's the same. They just, so this right here is clearly some fancy Python for getting the last segment. Just checking to see if it's there. If it is, it returns false. That would correspond to these 3 lines of code in my solution. And then, yeah. So this is basically just a Python 3 implementation of what I did. Although I probably spent more time than necessary validating that the input is correct. Because honestly, the description wasn't clear about what they were going to throw at you. So I just wanted to make sure that I had that taken care of. Okay, this is what I was talking about. Approach 2 is the trie-based solution, where you actually create a tree data structure to represent the file system. So there's another great data structure which we can use for approaching this particular problem, and that is the trie data structure. In order to read more about this data structure and other use cases, please refer to our Explore card. So here's how the trie would look after we've added A/B, A/B/C, and this is basically what I was saying. So all of the leaf nodes in the tree, so the nodes that don't have any descendants, those would represent like the longest path that you have. So A/B/C. So let's look at the algorithm. Yeah, I'm actually not going to bother reading the code. It's so what's the complexity analysis for the trie-based solution? O of t time if the trie contains t components, O of t time, and then the space complexity T nodes in the trie. It's basically, yeah, it's hard for them to specify what the space complexity is, but I think the big idea though is that it is going to use less space than the dictionary approach. So the space complexity for the dictionary is O of k, where k is the number of unique paths that we add. So interestingly, I think if I rewrote this with a trie, I would probably beat like 100% of JavaScript submissions on space, because with the dictionary solution, I'm already beating like 87%, and the trie does use significantly less space. Okay, I think that's it for this problem. Design file system, that was a good one. I'm curious about number of distinct islands, Mark II. Let's take a look at what that's about. Okay, so this is hard, but it's probably going to use, like, whenever you're talking about distinct islands or any kind of islands in a grid, the first data structure to consider is union find. So I'm just assuming that this will be solvable somehow using that. You're given an m by n binary matrix grid. An island is have I solved this before? No. Okay, good. An island is a group of ones representing land, connected 4 directionally, horizontally and vertically. You may assume all 4 edges of the grid are surrounded by water. Okay, makes sense. An island is considered to be the same as another if they have the same shape, or if they have the same shape after a rotation? I don't know about this. Or reflection. Return the number of distinct islands. Right, so this one, even though it has 2 islands, it only has 1 distinct island because these are the same shape after a rotation. Same with that one. Well, so step 1 of the solution is going to be just to find the islands. You could use BFS for that. So you go through the whole grid. Every time you find a 1, you just BFS and you'll be able to get the coordinates that are a part of that island. So that's actually fairly straightforward. But then once you know all of the islands, you then need to dedupe them. You need to be able to identify pairs of islands that are the same after you rotate or you reflect. I think, so probably what you need to do, this is kind of like almost like a geometry or like a math problem, but for every island, you would want to generate like a unique fingerprint for that island that where the same fingerprint will be created for that shape if it was oriented differently. So this is tricky. I don't know if I'm going to be able to do this. I'll think about it for a while though. So if you have 101, let's say that we run, so 111 like this, representing this island in the top left corner. Let's say that we take this island and we run it through a function and we get a unique integer out like that. We get that out. So what we want is for, let's say that later on we find an island that's shaped like this, which is that would be the island in the bottom right corner. We should be able to take that island, run it through the exact same function, and it should produce the exact same answer. Like that. This has to work for rotation and reflection. If you were to take this island in the bottom right and reflect it vertically, you would get this. That also happens to be a rotation, but for more complex shapes, the rotations and the reflections are going to be distinct. So this is hard. Exactly. How do you get the integer? That's literally what that's. So once we know that, the problem's easy to solve. Once we know how to get the integer is kind of like an ID or a fingerprint or like a signature. There's like a lot of different ways you could like name what it is, but it's a unique number for a specific shape where anytime you rotate or reflect that shape, you get the same one. So what how big is the grid? So the grid can't be larger than 50 by 50, which is pretty small. So we might have to make use of the fact that the islands have like a maximum size that they could possibly be. For example, the maximum size would be just the whole grid being filled by ones. That would be kind of a silly test case. So I think how many, so the fact that the grid is 50 by 50, that also significantly limits the number of islands you could have. 50 by 50. 50 by 50. We're looking at 25, the maximum possible area of the grid is 2,500. And that means that like the sum of all the total land masses of all the islands can't exceed that. I'm just trying to figure out if there's a way to use that to get this to the solution. So if you have, so the other thing too is, like when we have an island like 111, we could like imagine ourselves wrapping a rectangle around it to include like potentially some zeros. And then once we have that, this one's tricky. Let's just check the related topics. Hash, yeah. This is what I'm talking about. This right here, this conversion from like the shape of the island to a number, that's the hash function that we need to write. And then union find would be one way, but I was probably just going to do breadth first search. So we need to write a hash function. That takes into account all the rotations. Okay, so let's think about it this way. Let's say that we didn't need to take into account rotations and reflections. How would we write a hash function for this island? So for 1110, so I'm going to use that idea that I just mentioned, and I'm going to say that every time we're looking at an island, we're just going to take an imaginary rectangle and wrap it as tightly around the island as we can, so that we include the whole island, but also potentially some zeros. And I suppose there could also be zeros in the middle of the island. You could have an island that's shaped like this. I think this would probably be valid. Does it say that you can't have that? An island is a group of ones connected four directionally. That might mean that you can't have that. Maybe that has to be a 1 in there. Maybe there's no lakes. Maybe there's only islands. So in this case, what's the size? What's the grid? What's the size of this grid? This is 3 by 4. And so we want a hash function that's able to take a 3 by 4. Okay, well, so here's an important observation though. So if we have a 3 by 4 island, and then later on we find a 4 by 3 island, those should be treated basically the same way. And like we just rotate one of them. So what we basically do is we normalize it so that maybe like the smaller coordinate is always the first one or something like that. And then for square islands, it doesn't matter. So then the hash function has to store the location information of the ones on the grid. I don't know if I'm going to be able to figure this one out. This might be a little bit beyond what I'm capable of doing right now. For this one, This might be a problem where we go to the discussion and we like learn from someone else's solution. I might give up on this one, although I do think it's a really cool problem, and I want to know how to do it. I just don't know if I can figure. Like, I understand the concept, you know, like you got to be able to take. So once you find the islands, and like finding the islands is pretty easy. It's just breadth first search. Once you find the islands, you got to be able to take them, pass them through a function to generate a number. And if you were to have that same island later that's reflected or rotated, the function will give you the same number. Like, I understand the concept, I just don't know how to write that function. So I'm just gonna go take a look. Let's learn how to do this. Concise C++ solution using DFS and sorting to find canonical representation for each island. After we get the coordinates for an island, compute all possible rotations and reflections, and then sort them using default comparison. The first representation in this order is then the canonical one. Oh, okay. So the DFS is just finding the islands. So we don't need to look at that. Here, let's look at this. So we start the count off at 1. And then this is our answer. So they have a set of vectors of pairs of integers. And that set is representing the unique islands, because at the end we just return the set.size. So then we go through, we just have a double for loop written on one line for some reason, where we just go through, the grid. Every time we encounter a 1, that means that we're uncovering a new island. So we DFS it to find the island. And then this is where we go in all 4 directions. We're also overriding the value in the grid with the number of the current island. It's like island 1, 2, 3, 4, you know, so that we don't come back to it again. And we're creating it's creating a vector of all the coordinates that represent the island. It's storing that in a map. So basically what you end up with is you have a map that contains one vector for each island, and the vector for that island contains a list of the coordinates for the island. So after this function call here returns, this map count right here is extracting that vector that I just mentioned. Count is, like I said, count is it's kind of like an index for the island, but they started off at 2 because it's 1 by default, and then they pre-increment it before they go into the DFS. And the reason they do that is because they're overriding the values in the grid with the number, like basically the island's ID, and that needs to be at least 2 because 0s and 1s are what's in the grid by default. So the interesting part of the code is going to be this norm function. So map brackets CNT is going to return, it's going to produce a vector of coordinate pairs. So it's just like a list of XY basically. And so then this norm function is what converts that into a normalized form. so that rotations and all that are taken into account. So let's see how it works. So we get the vectors of pairs, v, and then we create a vector of pairs, s, which starts off with 8 things in it. Those 8 things, like this right here is, I'm not going to try to understand this. I don't think this is just mathy code for computing rotations and reflections. And the vector of size 8 represents all 4 of the rotations and all 4 of the reflections that you can do. Because is that right? Because you can rotate 4 times. You can reflect twice. But then you can also reflect and rotate, which could produce a different shape too. So I'm not gonna try to wrap my head around this, but what they're doing is they're creating the reflections and rotations here. Then they sort through it. They sort the wait, what is? Oh, okay, so they take each reflection and rotation and they sort the coordinates. Oh, okay, yeah. So this part right here goes through every coordinate of the shape. And for every coordinate of the shape, they have these 8 cases where they're moving the coordinates around to generate the rotations and the reflections. And then so after they update all the coordinates to take into account all the rotations and the reflections, they then sort that. Then they go through it again. And what are they doing here? I think what they're doing here is they're taking the coordinates and they're shifting them so that they're relative to the origin. So, like in the case of these 2 islands, right? The coordinates of this island are 0, 0, 0, 1, 1, 0, and 1, 1. Then the coordinates of this island are I don't even know, like 3, 2. No, 2, 3, 2, 4. Yeah, I mean, but yeah, you get the idea. But what they really need to do is they need to take these coordinates and subtract, like basically the coordinates of the top left, so that it moves it over to 0, 0. They need all the coordinates to be relative to the origin. And then once they do that, they sort all of the rotations and reflections, and then they just say the first one is the canonical representation. I feel like if I'd spent much more time, I could have come up with this, but I don't like being live on stream and just sitting here staring at the screen. But this does make sense. So they find all the islands with the DFS. For all the islands, they have a list of coordinates within that island that are the ones. So that represents the shape of the island. Then they normalize it. So the way they normalize it is they compute all of the reflections and rotations. They then sort those. They sort those. By sorting them, they make sure that the one with the lowest top right coordinate is first, right? So they take the one with the lowest top right coordinate and they have that first. And then that's why they're able to subtract L0 dot first here and L0 dot second, is because they know that the L0 is the rotation or it's the rotation or reflection that had a coordinate that's already closest to the origin. So basically they would find this top left coordinate of this island and they would know that that's the top left, and they would subtract the coordinates of that cell from all these other ones, effectively translating the island up to the origin is what they're doing. And then once they have that, they sort them again, and they just say whatever representation comes up to the front of the list, that's the canonical representation. And once you have a canonical representation, you just insert it into the set. And then by inserting it into the set, you're deduping it. And then you just have the set.size. That's cool. That's cool. I like that problem. So I'm not going to code it up because now that I've read the solution, what I actually am going to do is kind of put it on hold for later. I'm gonna like this problem, and at some future time, it could be tomorrow, it could be another day, I want to come back and try to implement it, having like a vague recollection of what the solution was. And because I think that'll be the best way to learn that. Okay, that was a hard problem. Let's move on to something else. If you have any problems to suggest, I'll take a look. Let's see. Let's try to sort this. Oh, I got to do my DP study plan for the day. So I'm currently in the Dynamic Programming 1 study plan. So yesterday I solved Fibonacci number and nth Fibonacci number. So today I'm going to try my hand at climbing stairs and the minimum cost climbing stairs. So let's take a look at those two. How long have I been live? I'm trying to do about a 2-hour stream, I think, because my brain was like frazzled after the stream yesterday. I did LeetCode for like 5.5 hours, and it was a little bit too much. Okay, all right, so I think what I'm going to do is I'm going to try to solve these two dynamic programming problems, and then that might be it for today, but I'll be back tomorrow with another LeetCode programming stream. Also important to keep in mind is that once I finish my LeetCode grind, I'm going to be doing other things on the stream that are software and programming related. Like I have some ideas for side projects that would be fun to build. Like I've got a lot of experience in web development. So like I know how to build like web apps and stuff like that. And so I have some ideas for fun little applications that I could build live on stream using like React for the front end and some other stuff for the back end. And I'm going to be doing that too. So this Twitch channel is not going to be solely interview prep and LeetCode grinding. It probably will have a lot of that for a while at least, but eventually I want to get into some other types of coding. Something a little more relaxing, because grinding LeetCode on stream, I don't know if you could really say that that's relaxing. Okay, let's take a look at this. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? I think I've solved this before. I solved it in May of 2020. But that was a while ago. That was over 2 years ago. So let's see if I can do it again now. I think the same thing for this one. This one I solved in July of 2020. Really fast solution though. Look at that, 16 milliseconds. And how did I do on this one? 48 milliseconds. 48 milliseconds in JavaScript. Let's not use JavaScript though. Let's use C++. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb up 1 or 2 steps. How many distinct ways can you climb to the top? So if n equals 2, let's look at the examples. If n equals 2, there are two ways to climb to the top. You can either do one step plus one step, or you can do two steps. If n equals 3, there are three ways to climb to the top. One step, one step, one step, one step, two steps, or two steps, one step. And n is less than or equal to 45. So this is dynamic programming, so I'm probably going to need a vector of integers dp. Is it going to be of size n? And then, importantly, what I always find useful to do in DP problems is try to verbalize and comment as best as you can what dp of I means. So dp of I, we want dp of I to mean number of ways to reach the ith step. So if we know the number of ways to reach the ith step in dp of I, then the answer to the problem is just dp of n, right? Let's uppercase this. Because that's what the question is asking, is like how many steps to reach the top. You have n steps. If dp of I is the number of ways to reach the ith step, then dp of n is the number of ways to reach the top. I think that's the way to think about this problem. So how many steps does it take to reach the first step? 0, right? Because you're already there. Yeah, wait, no, this is wrong. Hold on a sec. How many ways to reach the first step? Not how many steps, but how many ways? And I think it's one way. Like, the only way to reach the first step is to do nothing. And then this is dp of n minus 1. How many ways to reach the second step? It's also 1. The number of ways to reach the first step is 1, you just don't do anything. The number of ways to reach the second step is 1, because you just step from the first step to the second step. Then for int I equals 2, I is less than n plus plus I. How many ways to reach the ith step? Well, it's the number of ways. So it's the number of ways that it took us to reach the I minus 1th step. Plus the number of ways that it took us to reach the I minus 2th step. Is that right? Why does this just look like I'm implementing Fibonacci? So the number of ways to reach the ith step, and we already know how many ways it takes to reach the previous step, and we know how many ways it takes to reach the step before that. So it's both of those. And is that just it? Because you can go from the previous step and you can take a step to where you are. And you can go from the step 2 steps ago and you can jump by 2 to get to where you are. Is that right? Let's just run that. It's probably not right. Okay, that's the solution. Not only is that the solution, but that solution runs faster than 100% of C++ submissions. I did make one small change. Also, that's almost certainly a fluke. If I run it a few more times, it's going to run slower than that. 4 milliseconds, 0 milliseconds. It's just so fast that it's difficult for them to even compare the running time against everyone else's running time. The test cases are also probably really small. Like, if you look at the constraints, they're only ever going to give you n between 1 and 45 inclusive. So even if n is 45, this code runs instantly. This is linear time, right? They just have a loop that goes 40 times. Like, how long does that take on a computer? Literally zero time. So that's why I'm getting 0 milliseconds and 4 milliseconds. That doesn't actually mean that this is crazy optimal. That just means that this is as good as it can get. Like, literally everyone implements this the same way, and they all get a running time of 0 milliseconds. So I did have to change one thing. I had to change this to be n+1. And now I need to convince myself about why I had to do that. So dp of I is the number of ways to reach the I-1 step. Hold on, let me just check my text messages real quick. Okay, nothing that needs immediate attention, so my attention's coming right back to the stream. I mean, this is the solution, but I don't feel good about how I got it so fast without really understanding why it's working, especially the n+1 thing. Like, this makes sense to me, right? When you're at the bottom of the stairs, how many ways to get there? It just starts off at one way to get there. You just stand still. Then, how many ways to get to the first step? 1. You just take a single step. So then you start off at the second step. And then for each step, starting from the second step, you have to look at the previous 2 steps, and it's the number of ways you got to those summed together. And the reason you don't have to add anything right here, like, that's what I'm trying to figure out. Like, the reason you don't have to add anything is because the question's not asking how many steps did you take, right? It's asking how many ways you can get there. But it is kind of asking how many steps did you take, because you can either take 1 step at a time or you can take 2 steps at a time. But the answer is 3 because there's 3 different unique ways, like unique routes. There's 3 different unique routes you can take. This isn't really, this isn't counting the number of steps that you took. This is kind of like counting paths through a graph almost. Like, you could, if you really wanted to, you could represent this problem as a graph problem where each step is a node, and every node has an edge to the next node, but it also has an edge to 2 nodes away. And so you're not calculating steps, you're calculating how many paths are there through that graph, like unique paths. So if you really wanted to, you could probably calculate the answer using a traversal of some kind. I'm not going to bother doing that, although it might actually be a cool exercise. But yeah, so the reason we had to do... Oh, no. Okay, so this is right. It's the ith step, right? Because dp of n is saying how many ways to get to the last step. And then because of that, this dp of 0 is kind of like a base case because there's only n steps. So dp of 1 is representing the first step, dp of 2 is representing the second step, all the way up through dp of n, which is representing the final step. But you need this base case here for it to work. Even though there's no 0th step, you're basically, this is kind of like saying there's one way to like start the puzzle. There's, I think that makes sense in my mind. Like conceptually, even though there's no 0th step, you only have 1 through n steps. The dp of 0 is saying like there's one way to begin. Okay, that's enough of that one. Let's see if I can knock this one out as well. Let's do it in C++. Wait, what did I do it in last time? I did it in C++ last time. Let's do it in Python. Let's just do it in a different programming language. You're given an array cost, where cost of I is the cost of the ith step on a staircase. Once you pay the cost, you can either climb 1 or 2 steps. You can either start from the step with index 0 or the step with index 1. Return the minimum cost to reach the top floor. Okay. Pardon me. N is the length of cost. And then you're gonna have for I in range and like that's just you're just gonna have that. Like I can just write, or I already know that's gonna be part of the problem. dp is going to be our list, and it can just be, so in this case this problem is adds a slight twist to the previous one, because you're actually trying to optimize by keeping the minimum cost to get to each. So it's going to be very similar. Like you're gonna have dp of I mean, it's going to mean the minimum cost to get to the ith step. We'll make this range of n+1 again, because we're going to have the base case. And then the solution to the function is once again, you're supposed to return the minimum cost to reach the top of the floor. So once again, this is just going to be return dp of n. So dp of I is the minimum cost to get to the ith step, but now we're actually optimizing, so part of the solution is going to be to take a minimum, and because we're taking minimums, we can probably initialize the dp array to be like all really high numbers. They could all be infinity, and I need to refresh my memory on how to do that in Python. Python infinity. Okay, so there's math.inf. I don't know what the generally, I don't know, what do people usually do for this? That's what I want to know, right? Because it looks like I could do float of inf. It looks like that's an option, but it looks like I could also do math.inf. Like, I'm not entirely sure. Oh, in Python 3.5, you can do math.inf. So let's just use Python 3.5's thing. That's fine. We'll do from math import inf, and so that way we can just do dp is inf, and then we'll do a list comprehension. So for underscore in range n+1. Okay. Now, we need some base cases. So, dp of 0 is 0, I think. I think the base case for this problem is the cost is 0. Like you haven't made any moves yet. So you haven't used any cost, right? So then what's the cost to get to the first floor? Oh, hold on. There's a twist here. You can start from the step with index 0, or you can start from the step with index 1. But the other part is the same. You can climb 1 or 2 steps. So let's forget about the base cases for a second. We're going to start this at 2. So dp of I is still going to be, it's going to be a minimum. Oh, hold on a sec. Be right back. Okay, I'm back. So dp of I is going to be the minimum. We're going to have to look at dp of I minus 1. So dp of I minus 1 would mean we're taking 1 step to get to the current step. And then we have to incur a cost as well. So cost of I is the cost of ith step on a staircase. Once you pay the cost, you can climb 1 or 2 steps. Okay, so I think it's going to be the minimum of dp of I minus 1, dp of I minus 2, plus the cost of I, right? Because if you're, so we already know the cost to get to dp of I minus 1, and we know the cost to get to dp of I minus 2, and we don't have to, we don't want to re-incur the costs of those 2 steps, because you don't pay the cost until you leave the step that you're at. Right, and so once we reach dp of I, we then want to incur the cost of I, except we do need to subtract 1 from I here, just because of how we're going from, we're treating like 1 through n as the integers, the indices of the steps. So this works, but now the interesting part is you can start from step 0 or you can start from step 1. So dp of 1 is going to be, dp of 1 is going to be the cost of 0, and dp of 2 is going to be the cost of 1. Is that right? And then can we just start this at 3? Let's see. Okay, so that doesn't quite work. We got 30 and the answer is 15. So let's do this. Every time we update something in the DP array, we just print it out so that we can see what's in there. Interesting. So my code is saying the answer is 30, but the answer is actually 15. But if I look at my array, I do have a 15 in there. So maybe I'm just going like 1 step too far. I think I am. I think that I can rewrite this slightly and have it work. Let's see. Let's see if this works. Okay, so that's still not quite right. I was actually closer previously. Zero, 10, 15, 30. Okay, so if I subtract 1 from n, I get the right answer for that test case. Let's just try another test case, because that could have been a fluke. Yeah, it was. So for the second test case, let's just focus on the second test case for a second. Oh, interesting. Yeah, it makes sense that the answer for this one is 6, because if you look at the input, all these steps that have a cost of 100, you can just jump over those, because you can take 2 steps at a time. Oh, but I do have a 6 at the end here. Okay, so my code is working, right? My code is working because I'm printing. I can see that I end up with 6, like at the end of the array there. So, oh, that's interesting. This might have something to do with which step you start from. Let's bring this other test case back. So for the first test case, the correct answer is at index is not at the end of the array, which I'm slightly confused about. Yeah, I mean, we can look at these hints. I think we probably already figured all this out. Yeah, this is what we're doing. Oh. I see. So the question is not asking. The question is not asking what's the minimum cost to get to the top step. It's asking what's the minimum cost to get to the top floor. So if you're at the top step or the step that's right below that, both of those enable you to go to the top floor because you can take 1 or 2 steps at a time. So because of that, the answer is actually going to be the minimum of the last two elements of the array. I think that's what the problem is. So it's going to be the minimum of dp of n and dp of n minus 1. And so if you're at dp of n, that means you're at the top step and you're allowed to take one step to get to the top floor. If you're at dp of n minus 1, then you're one step below the top step, but you're allowed to take 2 steps to get to the top floor. And so whichever of those you reached with minimum cost is going to end up being the answer. So that passes the sample test cases. Now the real question is, how does that fare against the real test cases? It works. Oh, is it slow? Why does it look like it's slow? Okay, no, it's just really hard for the system to measure. Okay, there we go. So that is how you solve, I hope that made sense. That's how you solve LeetCode problem 746, minimum cost for climbing stairs. It's got an interesting twist to it, which is that the first twist is you can start either from the first step or the second step, but also you can finish either on the last step or the second to last step. But as long as you take both of those things into account, which is not particularly difficult, you can see how to do it right here, you end up getting the correct answer for the problem. Let's see, similar questions, climbing stairs, we did that, related topics, array dynamic programming, we knew that. It looks like Amazon's asked this question 8 times in the last 6 months. Yeah, I like the problem, we'll give it a like. Okay, so that's it. I completed my dynamic programming studying for the day. So that was day 2 of the dynamic programming study guide. It looks like tomorrow there's 3 medium dynamic programming problems to solve. So I'll be solving those on the stream tomorrow, and I'm a little bit nervous about them, but it's important that I do those. Just to review what we did though, if I go to my account, what problems did we do? We did 5 problems. So we started off with count binary substrings, which was pretty easy. Just easy simulation, brute force, just produce the answer really. Then encode and decode strings was interesting because for that one, you got to come up with your own scheme for encoding a list of strings into a single string. And so the solution that I came up with was to use an escape character, an escape character and a delimiter. But what I did find really interesting was that in the solution page, chunked transfer encoding was recommended, which is, it looks like a really powerful way to do this, where you basically have 4 bytes that represent the length of the next word. So you can see here, these 4 bytes are 3, telling you that the length of the next string is 3 long. Then immediately following that, you have another 4 bytes that represents 2. So you know the next segment is 2 long. So that's another way to do it. A couple of different ways to solve this problem. You can also, I did this as well. If we look at my submission history, you can see that my first submission ran really quickly with 79 milliseconds. And that's because I used JavaScript's built-in JSON.stringify and JSON.parse. That was my first solution, which they do expressly say not to do, but I did it anyway. And then I solved the problem properly after that. We designed the file system. That was a pretty fascinating one. There's several different approaches to this one. You can implement it as a trie or a tree data structure. You can also just implement it as a dictionary, and that works just fine. That's the solution that I ended up with right here. And then last but not least, we solved the 2 dynamic programming problems for the day. So that was the climbing stairs and the min cost to climb the stairs. And yeah, that's basically it. So that's going to be it for the LeetCode interview prep stream for the day. I'll be back tomorrow doing the exact same thing, so if you want to stop back in, love to have you. For anyone who was here watching, appreciate that, and hopefully I'll see you again tomorrow. Take it easy.